Hi there, my name is Sai Krishna. I am from LinkedIn. What I'm going to share is how we are seeing the overall white box evolution, how it is applicable to our environment. This is again here I am talking from the point of view of end user. We are one of maybe probably one of you guys, who'd like to build the bigger networks, scalable networks. How this open source initiatives would help. So to help the conversation, I thought of sharing what's our network look like today. So this is a multi-generation evolution from our point of view. We're building a brand new data center in Oregon. This is public information. You guys can read about it. We call it as a project Altair. This is our latest fabric design. As you guys see, we are one of the cloud providers or cloud companies. Our data centers are evolving. As the complexity of building the data center goes up, the best way to address the problem is simplify. Simplify means don't use complex protocols. How I can effectively build the network with much more simplified manner. That's the only way to cope up with the demand in the expansion wise and the capex, opex, everything what you say. This particular drawing, what you are seeing, is capable of. It is a 3-layer class network, very simple. It is designed to scale. As we go more and more horizontally, in the sense more and more server connectivity, I can easily add more port capability required. This entire network, which is capable of providing a connectivity of 100,000 servers, close to 100,000 servers, using a very simple primitive device. We kind of got to a point where eliminate the number of SKUs required in the design. It is a 3-layer, as I said, tar layer, spine layer, super spine or fabric we call. It is all designed using one single SKU. That we are using 32 by 100 gig form factor, which is a pizza box again, eliminate the need for any chassis or any of that. And good part is the latest generation of ASICs. It supports flexible speeds, 100 gig, 50 gig, 25 gig, 10 gig. We are taking advantage of all that, the ASIC level innovation. And with a very minimal oversubscription, we were able to provide 98,000 server connectivity. If we agree with, if the oversubscription is okay to go for 4.8 times, we can connect all the way close to 200K servers. 200K servers in any under one single roof is a mega data center. See, the reason why I'm sharing here is you could build a very complex network of this size with a one simple brick, so to say, pizza box, right? So to enable that pizza box, you obviously need various things. The way how I describe myself, the white black box to white box revolution, I kind of partition that into four different parts. ASIC. I'm glad to see all our industry friends here. This is good to see all the ASIC guys at one single place. Now I can choose and select whichever ASIC I wanted. Right. The next portion is the hardware box itself. Now, Cavium said we are building the box with OCP design. Again, that is open source. The platform building itself is again standardizing. That's the next layer. The layer up, which is more of a software. Now again, I am here to talk about the OpenSwitch as a NOS, how it is helping, that next layer. And then the more innovation comes on top of that, which is the applications. Glad to see quite a bit of, telemetry, visibility and all that. Particularly that is very much important. If you see this 3-layer class, the more and more if we design it and horizontally scaling all this, what happens is once the packet enters to this particular maze, there is no visibility today. Right? It's very tough to see why the packets are getting dropped, why the black holes are happening. all these things. Go forward visibility telemetry for this kind of a scalable networks is very, very important. And I'm glad to see there is a lot of activity in that. So with that context, this slide, I kind of, very busy slide. I'll simplify this in next slide. Just wanted to show the, the layers of what white box architecture blueprint for us means, right? You have the bottom, obviously the hardware we talked about, and then to build that network, you need some basic network features. Our mantra is simplify that as much as possible. And then the whole innovation for us is on the left side here, which is of, entire state information should be able to available for us to innovate. Particularly in our environments, how our applications are behaving, how our applications are performing, and all that. So this is essentially what I kind of see. OpenSwitch is going to help. But this thing we talked about, pizza box form factor, ODM vendor choice, and it gives you the flexibility of whatever hardware I wanted to pick, including the ASIC here. And again, in our environment, we have hundreds of thousands of servers. There will be a Linux distribution running on those servers. It will be better if we match that same distribution on the network switches also. That flexibility of Linux distribution of choice is one other important, particularly for tooling purposes and all. So on the right side, if you see network functions, the one big thing what I wanted to highlight is we don't want to bring any new exciting protocol for that matter of sexiness. Simplify, and a goal should be a minimum set required to make it function. That's the beauty of it. Reduce the complexity. And then the next portion is the entire network lifecycle automation. That is from the racking, powering on, to the cable connectivity, to now start routing, enable the routing functions, establish everything, and even the regular operational life cycle. So the whole thing, this automation process is evolution again. It is not like, I won't say, are we there yet? No, we have a lot more room to automate, reduce the human intervention. That's where we kind of going there. And these features we standardized upon. The network what I showed, it is a simple BGP layer 3 network. That's all it is. That is if you ask me my config file, that is the biggest feature. Rest of all are supporting feature, LLDP, BFD, and whatnot, right? So BGP, again, the BGP is also kind of going for crazy sub-features of BGP. It's simple enough. All it is doing is the route distribution, establish the flat network. That's all we need, right? Get to that. The beauty would be, hey, develop that in a community-based, right? And now if there is any innovation, the companies like peers to us would like to bring some other, excitement thing there, we can openly communicate, openly talk, openly contribute. LinkedIn is very proponent of open source, right? That's where we kind of see OpenSwitch would help in bringing all these things together. The next piece is, this is where we see this whole white box innovation would help. So far, we haven't seen, LinkedIn, I come from product companies, from my past. But if you look at it, the other side of the business, it's all about hackathon. Every simple feature or every cloud application they write, it is all about hackathon. Bring people together, and there is a well-defined APIs. Go for it. Every week they push a new feature. That side of the house. Why not to the networking? There is no such thing called a hackathon for networking. There is some, but I don't see at that scale. So the go forward, what I see is this is that, hackathon for networking. How I can enable it, right? So for doing it, we wanted to bring our cloud application toolchain onto the network infrastructure itself. That would enable us to, do more exciting stuff. this is one area what my team currently focused on is we call it as a entire switch state. Put it somewhere else, right? Stream the entire state information of the switch to a centralized storage for analytics, telemetry, visibility. That's the area where more exciting for us, and we could contribute more. But for that, obviously, these two pillars are very important. Hardware standardization as well as the community-based entire NAS, the full-featured NAS. This is the way how we see OpenSwitch would help. As part of it, we engaged with the OpenSwitch community for past couple of months now. As part of the contribution, as I said, LinkedIn is a very proponent of open source activities. We ported this stack to one of our own ODM, partner who we use the ODM platform. The same 32 by 100 gig platform, that one. BFD feature, which is missing from the DIL release. We coded that. We are in the process of upstreaming that. So I'm working with Michael to take it to in the master branch, right? So, just wanted to share. We've been actively engaged with the team here. And the next steps, what you see is basically getting this whole thing. Open source obviously comes with its own, challenges, stability aspect and all that, right? So, as an end user of this thing, we wanted to see how we can stabilize this and really see how we can go to the next level pilot and potentially deploy. So I am currently working on this thing. We call it as a the test bed test topology. This replicates. Colors are missing here. This replicates again wires and boxes. Anyway, this replicates the same topology what I showed at the beginning, 3-layer topology, right? In a mini version, obviously. But the idea is replicate all the features what we would be enabling in the production network, and we should be able to stage it, test it, and beforehand, right? So this is the network we are building in the lab. Looking for any partners who would like to contribute, fully automate this whole thing, and let it run. Because the open source gets churned quite frequently. Any new code we pull, retest that, the whole thing. So that's where we are focused on, right? So with that, whatever I spoke, we like to contribute back again. A lot of blogs we wrote, is welcome to read. Project Altair, that is the whole network architecture I kind of shared. There is a big blog about it. And then the Project Falco, that brick what I mentioned, which is part of the network creation. We call it as the Project Falco, which is a 32 by 100 gig. You can read about that one. The overall data center initiative, so that is also there. And last one, the open source at LinkedIn. Not only consumers, we have contributed quite a number of open source projects. One comes to my mind is the Kafka, which is the very successful open source project at LinkedIn. And in fact, we use that Kafka framework, which is the publish subscribe framework for our own internal consumption. So that's all. Quite a bit of a blog you can read.
So as you scale from hundreds, thousands to hundreds of thousands, or like on that one slide, like 96,000 ports.
Yeah.
And I'm not sure if any of you can answer this to a certain extent, and if it's being handled natively as part of OpenSwitch, is a problem that we all face as we scale and grow is spanning tree. I've got switches and switches and switches plugged into more switches, and then I'm hitting certain hard limitations, and there's certainly many ways you can carve that up. But as you have these hyperscale, massive growth environments, how are you guys handling that type of link aggregation, spanning tree challenges and problems in order to either, we ignore that completely and we want a different path, or we have a particular way to overcome it that we've chosen to go down?
Okay. So first thing what we did is we eliminated the use of spanning tree completely, right? So that's the first thing, smart move.
Answer.
Very simple answer, right? So we brought the layer 3 to the TOR itself. So in this picture, I'm not showing the actual server connectivity, essentially this is the top of the rack, right? Each box here represents the top of the rack. We got to a simplification. Even for any given rack, it's only one tower. You might have seen the designs with the dual tower. Then you have to, from server, you have to link aggregate, bonding and all that, complex stuff. To me, right now, it looks like a complex. Lag groups are so simple, but it adds the complexity if you look at it. The way how we designed is all applications are capable of taking care of failures, right? So when you have the layer 3 all over, spanning tree inherent problem of the redundant paths and loop detection is good, but redundant paths and once the double faults, triple faults happen, how the convergence happens and all that, it's really, really problematic. So having the layer 3 all over, all the way to the tower, it simplifies your life quite a bit. First thing you should look for is, end of the day, why you are using either STP or BGP or any of that, all you need is the reachability from point A to point B. In the olden days, you have the differentiation of router versus switch. Now that is not anymore. Every hardware device is capable of doing both, right? And BGP inherently has the advantage. Routing inherently has the advantage of taking care of multiple paths at the same time, and ability to react to the faults quite a bit faster. So that's the first thing. This entire network is BGP. As I said, my configuration file main feature is the BGP, and rest all is.
So y'all just go BGP to top of rack.
Yes.
And then just standard links down. Have y'all looked into shifting that access layer of BGP and peering down into the hypervisor, possibly with OpenSwitch or various tools that way?
Yeah. So I'll answer the question like this. If you instantiate the BGP into the server, remember now your total number of routing endpoints is going to drastically go up, right? So for each tower, kind of like let's say if this rack hosts 50 servers, 48 servers. Now for 48 servers, I have one BGP instance, right?
Right.
So the way how I am answering, in current environment, we don't use the virtualized infrastructure. We use native applications and we use the containers. Okay, so there is only one IP address to the server today in our environment. However, the servers also host some data center services like syslogs or DNS server, DNS service or some other. In those cases, it is acting as an end device providing the service for rest of the infrastructure. In those cases, there is a BGP instance on the server, but it is not the common BGP instance across the server pool. You got what I'm saying?
Yes.
So
you're running into the standard where you're just running out of AS numbers.
Yes. Yeah. In this case, we have plenty enough. But what I'm saying is, where needed, BGP instance needed in the server, we have it. And where we don't need, it's a plain, simple applications. We don't need BGP peering there. And that peering would be at TOR level. Yeah, you could go if you all your servers are virtualized servers and you have virtualized switching in there. Yeah, you could consider BGP all the way there. So you get the route tables into the server if that is your preference, or you offload it to TOR.
And you're just doing pure BGP, no like VXLAN on top?
No, not right now. Okay. So, but we are looking at overall tunnels. There are a few things we are looking at. The VXLAN or segment routing. But right now, the way how this network is designed is any server can reach any other server. But of course, we have the pools, the application pools. We will allow certain applications can talk to certain other application. In those cases, there are ACL rules put in place. And again, those ACL rules are all distributed across. So that way, from the network point of view, we wanted to get out of the way from the applications interactions, right? So network should not be our bottleneck. That's the whole idea about this flat network.
Nice.
So you've got this proof of concept running, OpenSwitch, and it looks, I mean, based on the fabric, it scales pretty big. How are you configuring that?
Yeah. So the configuration, we call it a zero-touch provisioning. Beauty of this is it is a cookie cutting. If you look at it, all I need to change is maybe the host name, right? And the interface is also common. All the uplink interfaces for this star, this star, this star, this star is same, right? Same last four interfaces. I use it as a uplink ports, right? So the commonization is your best friend, right? Don't try to differentiate in terms of configuration from one element to another element. If you do that, then your automation tools will have toughness. Once you have that commonality, all I am pushing is some variables, very few variables I have. IP address range from one device to another device change. The host name change or some other parameters, very hand-picked parameters.
Okay.
Because of that reason, I could automate the whole process of bring up to configure to manage it.
So you set a few parameters, drop it in, and it joins the fabric.
Yeah. So one other thing, probably this slide could help. Right. If you look at it, the hardware now, this new era of white boxes, all the hardwares are more of a ONI support. It's like a Pixie boot on the servers, right? The switches hardware doesn't come with any operating system. As soon as you power on, it will look for the image in centralized location. In this case, the DHCP server, whatever. It downloads the image, and at the same time, it downloads the you have some identifier, either a serial interface or a serial number or MAC address, whatever. Again at the centralized location, you have a pre-configured configuration template, configuration files. Just downloads, configures, and connects. That's the way how it is done.
I have a question more back on the what we had about spanning tree, and you talked about getting rid of it.
Yeah.
As much as I would like to believe that getting rid of spanning tree will fix problems, we all know that sometimes bad things happen. Did you guys investigate using any of the newer technologies like Trill or SPB? And that maybe is more of a question for the OpenSwitch architecture team. Do you support those in the OS? So, I mean, because one of the things that I've heard about moving to those technologies is that it's a huge pain in the rear to get them re-architected for something that, quite honestly, is a huge benefit for us. So I want to hear your thoughts, because this is obviously one of the bigger things that I've seen.
So let me answer you that particular question based on my past, experience. I worked, various other companies who invented the SPBs and, Trill and everything. That will not scale to this level. For example, if you look at the Trill, or if you look at the SPB, if you want under single roof this kind of a scale you want, it will have a tough time. Right? And another good point is having the BGP. We always use BGP as a eBGP external, but that has inherent capabilities of properties which helps you in scaling up to this level in a very proven manner. BGP is used to the entire internet now, right? The way how it distributes the routes, how it exchanges the routes, how it reacts to the faults and everything. That is what we need from the property point of view inside the data center. If you really wanted to have, the connectivity to 100K servers, if you look at it, it is around like 2K switches here in this diagram to provide you 100K connectivity. How I can uniformly connect to it, right? And the goal of reachability from anywhere to anywhere without any restrictions. All these things would very simply achieved. I would say SPB or Trill or any of that, it might achieve the similar goal, but I would say much simplified and proven manner is the BGP. So that's the way you kind of select.
I'd like to provide another answer. I'm not sure if Michael will agree with me, but I think that in this case, less is more. I think that one of the benefits that we have with building a project these days is that we don't have to carry legacy, which is less relevant. For example, Trill was supposed to solve a problem where you cannot move a VM from one place to the other because there was a router somewhere there. Once VXLAN was introduced, the problem is gone, and Trill has gone with it. So I think that we have the luxury of not investing in such protocols because the problems that they were trying to solve are gone. So I think that this is actually a strength that we don't have like other companies that have like 20 years legacy. This project has the luxury of choosing the right technologies without carrying some old stuff, which is, let's say, less relevant these days.
We don't see anybody in the community actually proposing to contribute Trill support or SPB support. So we as HPE, we don't have any plans to do it. And I don't see anybody actually talking about use cases, requiring it, saying, I will develop, I will contribute.
So are you providing customers, say, a roadmap to say, forget what you're doing today, BGP is the future, effectively? I mean, because a lot of people are doing a lot of really bad things today, or sometimes it was their only option. So whether they're doing SDP, MSTP, they've got a whole convoluted series of different interwoven connections and, PVST, everything tied together because that's what they could, that's all they could do. And those were their options. So it's the concept of we can use any hardware we want. It's running on Broadcom, so the silicon's fast, it's powerful. The ASICs will do whatever you need to do. All of our limitations of the past were hard limitations because of math. Mm-hmm. All those problems are away. Now we just have limitations set into the code. It's like 255. Why is it that? Because that's the number we used to use, or 256 respectively, or 254, whichever way we look at it. We don't have those as hard limitations against us now, but if the answer is, if you replace everything you have with something brand new, your problem is resolved. But that's not always the option of today. It's you can implement certain parts of it, and thus, how do we get into the interoperable journey so we can start to transition people off of bad ideas to future-proof concepts and have it be successful as opposed to, a fiery train wreck?
Maybe I can take go at answering that. I think you're absolutely right that those who have been trying to build the very biggest data centers have already pioneered this track, right? So all the big mega-scale data centers have moved towards either BGP or something very much like it. Why is that? Because they can. They've written their own software. They've already broken apart these closed proprietary systems and said, if we can make it simpler, we will. We'll throw out all the crap we don't need, and we will just use BGP because it works, right? And so that's been a very, very common thread. What this enables and what OpenSwitch enables is to bring it to the next set of users who don't have armies of software developers who can do that for themselves. And so it makes it available to others who want to ride on those coattails. Now, to your point of interoperability and making it work with other stuff, this is the great thing about BGP. They can start by doing it with a standard IPv4, IPv6 distribution method that allows it to interoperate. And so it's a nice, easy insertion to start with. But the benefit of being able to change the control plane and then eventually the operating system and then eventually, hopefully, the forwarding plane as well is that you can allow those, probably the mega scale guys to start with, to experiment with new ideas. Hey, maybe someone will try out source routing, right? Let them try it. Let them try it if they want. This provides people to experiment with that. Good luck. But some people will try all sorts of new things. And that's when I think we'll see some really exciting things. Mm-hmm. And the benefit inside a data center is you're generally talking server to server, so you can try out these ideas in a safer environment. So I think that OpenSwitch is very exciting from the point of view of opening up all those possibilities. Mm-hmm.
I totally agree with Nick. That's one particularly the benefit we have in our environment. As I said, right, this network design, even in our environment, it evolved over the years. We do have certain deployments with STB. Whether we will do the same way again? No, it's gone. Right? It's tossed out of the window. Look for a new way of doing things. Right? The idea is simplify. As long as you carry that legacy, bad luck. you have to worry about the interoperability. And you have to worry about how you support it. But as you move forward and start building up the new designs, now instead of reusing the same templates what you've been using, you start looking at the new design models. Right. So that's the way how I look at it.
And, I was going to say, do you have papers, references, stuff along those lines to actually say people have started to go through that transition, and here's examples, use cases, examples, so people are able to start to see that we can actually go in this direction. Because to say, people often throw us around, we want to be like Facebook, we want to be like Google. Google has like 8,000 applications. Google is very specialized, they do their special stuff. LinkedIn has very specialized applications. Most people are using off-the-shelf applications and stuff that they bought from someone else, and they have to kind of make it all work together with a whole bunch of end users. Whereas it's just, sometimes it's a different problem, but it's the same problem. We're all dealing with silicone and a bunch of ports. We all have, same issues, but giving them a sense of someone has done this, they didn't build it from the ground up, and here's a transitionary roadmap and plan of how they want to go about getting to there, and that can help make adoption of OpenSwitch much easier. It's like, hey, here's go the direction of OpenSwitch because we have ways to actually do it. Here's someone else who did it, so you don't have to feel like you're the first guy ever doing it.
I think you're right that those, the Facebooks and Googles have described and published it in detail what they did, but of course they had the armies of developers in order to let them do it. And so I think this is kind of chapter 2, right? That was chapter 1. The big guys went in and said, this is what you can do if you can actually go in and program it for yourself. And now we're seeing, bringing it to a much larger audience, the ability to do that for themselves with things that, because of the QA benefits that you get from a large open source community, means that they can trust it, even though they haven't developed it themselves. So I think this is...
I think that's also why you start to see it a lot of, you're seeing the traction pick up for virtual networking. When we have to deal with these messes at the network layer, we have to bring stuff in like MLAG and different things like that to be able to trick the network into passing traffic or put an overlay on top of it, shift that all down into hypervisor and let it deal with it. We're just dumb pipes at that time. I think that's why you're seeing a lot of stuff go that way as well.
Yeah, one good part is, a lot of blogs about it. Obviously, we are the end user. We are not trying to sell any of this. We are coming out, and sharing this. Exactly that. Say tomorrow you bought into this and you start contributing and you start sharing as well. So that way we kind of learn from each other. From that point of view, all cloud companies are very openly talking about it and blogging about it, but we don't have obviously a prescribed, a document. Hey, this is the way how we do it. Somewhat of an investment has to come from, the
community,
yourself, community, and be part of it. But there is a lot of help. You have to look for it. And particularly if you look at it, what I'm advocating here is you would be able to create this kind of a scalable network with a very simple one, and making use of various nuts and bolts. It's not like you are there, trying to unscrew and rescrew it again. Now there are so many Lego pieces coming together to really give you, what you are looking for, which was not the case maybe 6 months back or 1 year back. Things are, progressing very well in that direction.
Best practices, methodologies, and don't do this because we saw that. It's all, and driven by the community especially, but that helps to increase adoption. Absolutely.
So I think there's one story that I think is really interesting that I think is very common to people that run big data centers, and that is something breaks. What do? They have to get the compute, the storage, and the networking people into the room to figure out what broke. In the past, the compute people could bring lots of logs, lots of experiments, reproduce the error, and be able to debug it. The storage people to some extent. The networking folks have ping and traceroute. What this does is it changes it because it means you can actually actively take part in creating experiments, logging things that you're looking for, conducting experiments to try out fixes in a way that you just couldn't do before. And so I think that from that point of view, it's empowering those who own and operate these networks in a way that we've never seen. So I think this is what all of these open source projects in networking. Think about it. 7 or 8 years ago, if you'd said open source networking, that didn't make any sense at all, right? That's just an incredible revolution, and I think this is taking it to a whole new level.
Yeah, it's very exciting, which is cool.